I'm here to present a research I did during my master's degree in road and transportation engineering, which is titled Modeling the Operational Performance of Atomic Interchange to Improve Congestion and Environmental Pollution. This is a case study in Ghana, Accra. And my co-authors are Professor Charles Anum Adams and Dr. Ose Kwame Kwakwa of Regional Transport Research and Education Center, Kumasi, here in University. Below outlines a brief of my research. So my research includes introduction, problem statement, research aim and objective, methodology, research and discussion, conclusion and recommendation. Introduction. Interchanges play a crucial role in transportation system, enabling the smooth movement of vehicles and people between different roads and highways. In Ghana, transportation infrastructure faces challenges with congestion and safety concerns at intersections being prominent. The interchange at Atomic Junction, Tetekwashi, Malam interchange frequently experiences traffic congestion during peak periods, that's in the morning and in the evening. Several studies have shown that roundabout interchanges can reduce delay and queue length compared to traditional signalized intersection. This study was done by Bird and Masood, 2018, Chen et al., 2020. Regular congestion increases the queue length of vehicles and travel time delay, causes high emission NOx and fuel consumption. The implementation of effective strategies geared toward reducing air pollution, promoting sustainable transportation practices, and enhancing urban planning contributes to the attainment of SDG 3, that's health and well-being, SDG 9, that's resilience and sustainable infrastructures, SDG 11, that's creation of sustainable cities and communities, and SDG 13, that's climate action. Problem statement of this research. In Ghana, major arterial roads faces challenges with congestion concern at intersection being prominent. The proposed remedies of roundabout and Rabi interchange offer potential solutions to congestion, but their efficacy remains uncertain. The interchange spanning from Atomic Junction, Tetekwashi, and Malam interchange frequently experience traffic congestion during peak period. This underscores the need for improved operational strategies and innovative enhancements. Congestion profoundly affects transportation and is associated with elevated accessibility and mobility levels. This leads to the squandering of time and energy, environmental pollution, heightened stress level, diminished productivity, and increased societal costs. Causes of congestion include poor signal operations, roadside friction, and inadequate road infrastructure. Building new roads may not always be possible due to space and budget constraints. To alleviate congestion, low-cost solutions like optimizing signalized intersections and creating slip lane or additional lane can be exploited. Main research problem. So the image here was captured on Google Earth to depict the traffic condition at Medina interchange. So the first image here captured the traffic congestion situation during 8 p.m. And the other one here also indicates the traffic condition during morning. This was captured around 8 a.m. in the morning. So you can clearly see the red zones, which indicates the traffic congestion along the runabout and also the exit and entry of the runabouts, same as the morning ones. So an image of a photograph of the existing condition captured at Atomic Interchange during afternoon section is this. So you can see the traffic congestion at the Atomic Interchange. Aim and objective of this research. This study aimed to comprehensively explore strategies to improve the operational performance of the Atomic Interchange. The specific objective includes to establish the existing operational performance at intersection through micro-simulation, to investigate an unsignalized intersection improvement options for the intersection, considering minimal intersection geometric modifications, to investigate a signalized runabout improvement options for the intersection by varying the phase plan. Methodology. The methodology of this research includes field data collection that was collected using the metro counting and manual enumerator to collect the traffic data. I then created a model using the VSIM, and also to check for errors between the field data and the simulated data. There was a need to check the correlation between the field data and the simulated data. So I went by the GEH statistical method and the t-test statistical method to check the correlation. If indeed the data I captured on the field is accurate once as I simulated. Then I went to results and analysis to show how best I can exploit for the improvement of the intersections, and went to check for the various scenarios which best fit to solve this situation, and came up with recommended. So the area of study of this research focused on the Atomic Interchange, a critical transportation hub along the N4 road in Ghana, connecting Medina and Atomic. Despite its importance, historical Google traffic image reveals significant challenges, including high traffic volumes and congestion during peak hours. The interchange features a central runabout with 4 intersections, with 4 intersecting routes, serving as a crucial link for Medina Estate, Hatcho, Medina or Adenta, and Legon. The study aimed to address traffic issues by implementing design elements such as a throughput ramp, a 4-legged base runabout, and a dedicated lanes for northbound and southbound traffic from Legon Presec and Adenta, respectively. The goal is to improve overall traffic flow in the area as depicted in the accompanying image. So the image here indicates, this section indicates the westbound, that's from actual. And this section also indicates the northbound, that's from Legon Presec. And this eastbound indicates those who come from Rolling Circle or Medina Estates. And the southbound indicate those who come from Adenta. Below indicate the elements of the atomic interchange. So as earlier discussed, those from Acho are at the west side. Those from Medina Estate are from the east side. Adenta from south, Legon from north. And the following are the parameters of the interchanges. Field data collection. The field data, before we went to visit the site, I had already captured the traffic Google image. And I went to the site to also confirm using the field data collection. The study utilized pneumatic tube counting device and manual and rater method to collect the classified traffic data, volume data. The classified volume data was then categorized into small, medium, and large groups. The medium vehicle classification was later converted to heavy goods vehicle using a conversion factor of 1.7. Travel time and queue lengths were also collected for calibration purposes. Then I went on using the PTV VSIM software to do my modeling. So the image here indicates the installation of the metro count device, which I used to collect the throughput. That's those vehicles which are flying through the flyover. And the runabout was collected using the manual traffic counts method. Okay, so in order to check the correction of my results, I went using the GH statistical method that was adopted by Geoffrey E. Harvest, and also the t-test statistical method to check the to serve as a quality control test for my results. The calculation of GH statistics applied to mainline segments, ramp outline in the project scope, as well as throughput volume at all entry and exit location in the model calibration zone. So the table here is a statistical t-test that I conducted to calibrate the travel time, the field travel time compared to the simulated travel time. So the level of significance I was getting was around 0.32, which the specification shows indicates that the level of significance should be greater than 0.05. And my results I was getting was also greater than 0.05. So it means I can proceed with my simulation, and also which means that the data I collected was accurately enough to be used for my research. Same as the GH statistics, which was adopted by Geoffrey E. Harvey, and mostly used by Federal Administration, Highway Administration. So with the GH statistics, traffic data, the volume of traffic data were on the field, collected on the field, were compared to the simulated volume data. So with the GH statistics, simulated flow rates were deemed accepted, where the GH statistic was below 5. a range of 5 to 10 for the GH statistics that suggested potential adjustment might be necessary for the model. However, if the GH statistic exceeds 10, it raises concern about potential issue with either the model or the data which I collected. So checking from here, all my data I collected were ranges from 0.46 and even somewhere less than 0.2, somewhere even less than 5. Most of them were less than 5. So it doesn't raise any concern about the data I collected on the field. Okay, so I went on to use my simulated data to compare the level of service. So the level of service for the runabout and the turning movement on the runabout Legon to Medina Estate, I was getting level of service F according to the highway capacity manual, which means there were a lot, the section is very, very congested and is very restricted. And safety-wise, it's not good at all. Legon to Adenta to our serving level of service D, which indicates that still the traffic volume was very high and the delay pattern was also very high. Same implies to Medina Estate to Hachu. All this section that I'm getting F means the delay pattern is very high and very restricted for vehicles to maneuver. And their safety concern is also at risk. The only sections which were giving me a less level of service was the usage of the flyover. Without those ones, I was getting level of service A and B, which was very good to use. The only sections which the congestion is mainly concentrated is on the turning movement. So overall, the level of service at Atomic Interchange was giving me F without the flyover, and with the flyover, I was getting level of service E. So I went on to check how best I can improve this situation at the intersection. So first of all, I went on to introduce an exclusive right turn slip lane from west, that's from Hachu approach towards Legon. A dedicated exit lane was established on the westbound, that's Hachu approach, facilitating seamless movement for vehicles transition from the Hachu direction to Legon. This initiative effectively segregated turning traffic from the traffic moving straight ahead, mitigating congestion and permitting turning vehicles to decelerate without impeding the velocity of vehicle proceeding on the main route. The simulation-based evaluation of the new introduction slip lane within the runabout intersection demonstrated a notable enhancement in the operational efficiency, reflected in level of service E. After introducing the slip lane, I had level of service E and a vehicle delay of 35.39 seconds with a queue length of 78.3 meters. The proposed incorporation of the slip lane is depicted in the figure below. So you can see from here, I introduced a slip lane from Hatcho towards Legon. And it reduced the traffic congestion at the roundabouts, giving me level of service E. So I went on to proceed for another option, which I can assume it can improve this congestion. So I went on introducing 4-phase signalized intersection with an exclusive right slip lane. And with this one, I was also getting a level of service E, which means still the improvement couldn't pick. So I went on to option 3 by optimizing the signalized signal phase. So either I change the phase timing. I change the phase timing to a different phase time to check if it can optimize the traffic situation there, which I did, and I had level of service D. But at this time, I reduced the signal hertz to 3, which helped a lot and reduced the traffic situation from E to D. I went on to further come up with a different option, which included expansion of the runabout by widening the approach roads to 2-lane entry and 2-lane runabouts. And at this section, those from Hatcho, and also those from Medina Estates, I increased the width of the road to 2-lane, which helped to reduce the traffic situation from D to B, level of service B, which indicated a very good traffic performance at the intersection. So below, I want to show you a short video of how the improved traffic situation will be if we go by the expansion of the road from Hatcho and also from Medina Estate. So we can see the simulated the simulation of the interchange by introducing additional 2-lane from Hatcho and also from Medina Estate. And this reduced the traffic condition from E to level of service B. Okay, so a summary of the data I collected is here, with the base being the existing interchange, level of service E, and also option 1 getting level of service E, option 2 getting level of service E, and option 3 getting level of service B, and option 4, which I introduced the 2-lane from Hatcho and also from Rollins Circle, I was getting level of service B. So here you can see the vehicle delay, the base, I was getting 49.84, which means that travel time delay was very high as compared to the rest. But at the last option, which I introduced 2-lane from Hatcho and from Medina Estate, I was getting vehicle delay of 13.09, which indicates a significant reduction of the congestion. Also, fuel consumption, you can see because of the delay, there was an increase in fuel consumption from the base section, level 1, option 1, option 2, option 3. But for the last option, the fuel consumption reduced, which means option 4 widening from Hatcho and also from Medina Estate will be the major way of reducing this traffic situation. So I went on by checking the emission notes of the percentage of emission notes. So with the base being the existing of interchange, I was getting an emission notes of 28%. Option 1 it's reduced to 23, and option 2 it's reduced to 18. Option 3 reduced to 17, and the last option, which was I deemed to be very favorite for the improvements, I had an emission loss of 14%. Same as the vehicle delay histogram showing here for the various options. So the pie chart and the histogram above depict that option 4, which involved the expansion of roundabout by widening the approach road to 2-lane entry and 2-lane roundabouts, exhibited the lowest emission noise and the shortest vehicle delay. These findings are particularly relevant in the context of Sustainable Development Goals, SDG, for 2030. To summarize the endeavor to combat declining air quality due to exhaust emission from congestion traffic align harmoniously with multiple SDG. This SDG include SDG 3, SDG 9, SDG 11, about under the existing operational.
Okay, thank you.
The runabout under the existing operational experience high delay, long queues, and environmental sequence of emission. Option 1, which involves introducing an exclusive right-turn slip lane from Hatcho to Legon, has the lowest cost due to its focus on implementing a slip lane. However, it results in significant prolonged traffic delay. Option 3 demonstrated a moderate delay characterized by level of service D, whilst option 2 incurred a more prolonged delay marked by level of service E. This suggests that option 2, with its higher delay, may not be enhancing the interchange. The most favorable option is expansion choice involving a 2-lane addition, which achieved the highest level of service B. This choice has the potential to decrease vehicle delay, queue length, as well as emission noise and fuel consumption. In summary, addressing air quality issues caused by congestion traffic align with various sustainable development goals, including the SDG 3, SDG 9, SDG 11, and SDG 13. In sequence of developing similar interchange, there should be a geometric design consideration of widening east to west into a double lane to ease congestion. Recommendation: based on the finding of this study, the current state the current congestion issue at the interchange underscores the need for immediate action and prolonged strategies to alleviate traffic bottleneck, optimize traffic flow, reduce emission into the environment, and enhance overall transportation efficiency. This will combat declining air quality due to exhaust emission from congestion traffic, aligned homogeneous with the multiple SDGs. Thank you very much.